Mole conversions are going to be one of the most important concepts you'll learn in chemistry, so this video serves as a review of some simple calculations involving mole conversions. Remember, in chemistry, mole is the ultimate unit. Once you're in the unit of mole, you can go practically anywhere. We're going to look at two conversions. We're going to look at the conversion between mass and moles, and then the conversion between particles and moles. Depending on what you're looking at, a particle can be an atom, a molecule, or a formula unit. A formula unit is just a fancy way for right now of saying a molecule. It's specifically for ionic compounds. Alright, basically mole conversions are dimensional analysis, and you're just using conversion factors in order to get from one thing to another. When you're going between mass and moles, since every compound has a different mass, you need to look at the molar mass of that compound. When you're going between moles and particles, since this is an amount or a quantity, it's always going to be the same. 6.02 times 10 to the 23rd. This is known as Avogadro's number. In chemistry, we're going to add the fourth digit just to be a little bit more accurate and precise. So we're going to use 6.022 times 10 to the 23rd. But this video is just going to look at the basic idea. So let's look at an example. Alright, how many formula units of calcium chloride, CaCl2, are there in 27.6 grams of calcium chloride? The molar mass of calcium chloride is 110.98 grams per mole. And then, how many atoms are in the same mass? Alright, let's answer the first question. The first question says how many formula units of calcium chloride are there in this mass of calcium chloride? Remember, a formula unit is just basically a molecule. Okay, so let's look at what we're given first of all. We're given 27.6 grams of calcium chloride. It's always important to write the formula as well so you don't get confused, because sometimes you'll be switching back and forth between one compound and another. Okay, now if you remember from dimensional analysis, we need to set up our roadmap. We're currently in the unit of grams, and we want to get to formula units. I'm just going to put Form U for short. Alright, do we know a direct conversion between grams and formula units? There is no conversion to get us directly from one thing to another. However, we can get to the unit of moles, and then once we're in moles, we can then get to formula units. So there's going to be two conversions involved in this step. The first step is we're going to have to convert from grams to moles, and then the second step we're going to have to convert from moles to formula units. So just like dimensional analysis, let's set up our conversion with units first. Do not put numbers in first. Okay, so since grams is on the top over here, it needs to be on the bottom right here. So I'm going to go ahead and put grams of CaCl2, and then moles of CaCl2 goes on top. Now take a look at these units. We're looking at a conversion factor that involves grams and moles. Remember, this is your molar mass, and we're given that in the problem. We know for every 1 mole, it's going to weigh 110.98 grams. So now we can fill in those numbers. For every 1 mole, it's 110.98. This is why it's important to write the units first, because sometimes students like to put the number 1 on the bottom by habit. And the number 1 doesn't always go down here. In fact, sometimes there's not even number 1 at all. The numbers are always changing depending on the problem. So you have to write your units first. Alright, grams will cancel out, and now we're in moles. We've completed the first conversion. Now we need to get from moles to formula units. So let's set up that conversion. Alright, we're going to put moles of CaCl2 on the bottom, and we're going to formula units, since calcium chloride is an ionic compound, so formula units. Alright, now let's go ahead and fill in our numbers. For every 1 mole of anything, in this case calcium chloride, it will have 6.022 times 10 to the 23rd formula units. The moles cancels out, and now I'm in formula units. So now I'm ready to calculate. When I multiply everything out and I divide and I make sure that I have my correct significant figures and my correct scientific notation, I end up getting my answer is 1.50 times 10 to the 23rd formula units of calcium chloride. Alright, So that answers the first question of how many formula units there are in that mass, 27.6 grams. Now the second question is asking how many atoms would there be in the same mass. We're looking at the same mass, so that's important because this means we don't really have to redo any of this work, which is good news for us. So it's asking how many atoms there are in that same mass. Okay, let me get these things matched up. There we go. All right, I want you to think about this. Let's say you had exactly one molecule of calcium chloride, just one individual molecule. How many individual atoms would there be if you had one molecule? Well, you'd have 3. You'd have the 1 calcium atom, and then you'd have the 2 chlorine atoms, so a total of 3. Okay, let's say you had 2 molecules of calcium chloride. So let me write this out so we can kind of see this. So we said for every 1 molecule, you would have 3 atoms. If you had 2 molecules, how many atoms would you have? Well, think about it. If you had 2 calcium chlorides, so let me write another one here so we can visualize it. Look at that. You would have 6. You'd have the 2 calcium atoms and then the 4 chlorine atoms for a total of 6. Now, you can probably think about where this is going. Okay, if I said we had 3 molecules, you would have 9 atoms, and so on and so forth. So notice what's happening here. For every number of molecules so we see for every molecule that we have, I think I cut out there a little bit, I'm sorry. If we have 1, 2, or 3, you're always going to have triple the amount of atoms. So on and so forth it goes. So let's say you don't have 1, 2, or 3, but you have this many, which is quite a lot. But it still applies. If you have this many molecules, which is quite a bit, you know you're going to have triple the amount of atoms. So all we need to do is we just need to take this number and multiply it by 3 in order to get our number of atoms. So if I do that, I end up getting my answer with appropriate sig figs is approximately 4.50 times 10 to the 23rd